We're going to look at questions on the topic equations and inequalities. Part A, we're supposed to solve for x in the following: x squared minus 2x minus 35 is equal to 0. To solve this, we need to factorize this quadratic function by finding the factors of minus 35. Factors of minus 35, which when added will give you minus 2. And those factors are minus 7 and 5. Minus 7 times 5 is minus 35. Minus 7 plus 5 is minus 2. So those will work perfectly. We factorize x minus 7, x plus 5 is equal to 0. According to the zero product law, it means either the first bracket is equal to 0 or the second bracket is equal to 0 for it to have a right hand side of 0. So either x minus 7 is equal to 0, which means x is equal to 7, or x plus 5 is equal to 0, which means x will be equal to minus 5. So the possible values of x are minus 5 and 7. Part B is an inequality. So to solve for x in that inequality, first we're going to factorize the left-hand part like we did in part A. If you look at this is actually a difference of two squares. X squared minus 16 can be expressed as 4 squared. So that's where the difference of two squares is coming from. So this is factorized as x minus 4, x plus 4 greater than or equal to 0. To find x, we don't use the same line of solutions as we did with part A, because an inequality gives us a range of x values. So instead, we first point out what critical values of x there will be in this function. You can see from this factorization that our critical functions are minus 4 and 4. Then we construct a table of critical values where we're going to test various values around these critical values and see how our function will react. So for the first bracket, x minus 4, in this column here, I'll be substituting values that are less than minus 4. For example, minus 5, it can be minus 10. If I substitute that, my overall bracket would actually still be negative. So you just write the sign there. Then I substitute minus 4 into that bracket. It would still give me a negative value. Then I'm going to look for a value that is between minus 4 and 4. For example, 0. If I substitute, I still get a negative value. Then I'm going to substitute 4. 4 minus 4 gives me 0. Then I write my 0 down. Then in the last column, I'm going to look for values greater than 4. 5 minus 4, for example, will give me a positive value. So that's your first bracket, x minus 4. Then for x plus 4, I do the same thing. I'm going to substitute a value less than minus 4. This function will be negative. If I substitute minus 4, this will be 0. If I substitute a value between minus 4 and 4, this will give me a positive value. If I substitute 4, it will still remain as positive. And if I substitute values greater than 4, again, it will remain positive. And this is for the second bracket. Then I'm now going to work out the overall signs for my function. My function here is a combination of the two brackets. A negative and a negative gives me a positive. A negative and a 0 gives me a 0. A negative and a positive gives me a negative. A 0 and a positive gives me a 0, and a positive and a positive gives me a positive. The function says it's greater than or equal to 0. So I'm looking for values that will satisfy greater than or equal to 0. So it means I'm looking for the positives and the zeros only. So it means my value of x will range from negative infinity to minus 4, because this is where it's positive and 0. And we'll also consider values from 4 going to positive infinity. Part C involves exponents. 9 is multiplying 2 to the power of x minus 1, and this is equal to 2 times 3 to the power of x. To be able to solve an equation with powers, it means we need to use the laws of indices to solve this. There are multiple approaches. The first approach would be to change the 9 into a base of 3. So this is the same as 3 squared multiplying 2 to the power of x minus 1. And this is equal to 2 times 3 to the power of x. Then I'm going to group the like terms. I'm going to divide both sides by 2 and divide both sides by 3 squared. So this will be equal to 2 to the power of x minus 1 divided by 2 being equal to 3 to the power of x divided by 3 squared. According to the laws of indices, if we are dividing, it is the same as subtracting your powers. So this is the same as 2x minus 1 minus the 1 from the denominator. This is equal to 3x minus 2. The 2 is coming from the denominator. Simplify this. This is equal to x minus 2 being equal to 3 to the power of x minus 2. So we now have the same powers. If I divide both sides by 3 to the power of x minus 2, it means my right hand side will be equal to 1. According to the laws of indices, anything raised to the power of 0 is equal to 1. So if I raise 2/3 to a power of 0 on the right hand side, I would have not changed anything. At the same time, I can rewrite my left hand side as 2 over 3 to the power of x minus 2, and this will be equal to 2 over 3 to the power of 0. So now I have the same base on the left, same base on the right. So it means I can just equate my powers now to find x. Therefore, x minus 2 is equal to 0, which means x will be equal to 2. The second approach to part C, we're still multiplying 9 by 2 to the power of x minus 1, and this is equal to 2 times 3 to the power of x. The second approach would be to deconstruct this 2 to the power of x minus 1 using laws of indices. It's the same as 9 times 2 to the power of x divided by 2, which is equal to 2 times 3 to the power of x. Then I'm going to multiply both sides by this 2 in the denominator here. So 9 times 2 to the power of x would now be equal to 4 times 3 to the power of x. This 4 is coming from 2 times 2. Then I'm going to bring my unknowns to one side, so it means I'm going to divide both sides by 3 to the power of x, and then also divide both sides by 9. So this becomes 2 to the power of x divided by 3 to the power of x is equal to 4 over 9. I can rewrite this as 2 to the power of x over 3 to the power of x being equal to, I change 4 to a base of 2, it's the same as 2 squared, and I change 9 to a base of 3, it's equal to 3 squared. And matching base for base, you can actually see that x will be equal to 2.